Hello, hello, hello. Hey, we are moving into a whole new world. We're going to be talking about equivalent expressions. So you're going to have to understand this world. Now we're going to add our integers into this. We're going to add some rational numbers in with this. We're going to stay a lot with the integers. But what we're going to be talking about first is there's a key word here called equivalent. Okay, so now when we look at this, we just want to understand what that word means. Now in class, we're going to do an activity called Faces of Equal. So I don't want to share too much of that because we're going to talk about it in class. Okay, but let's look and see what we're doing. You can see we've got some things coming up. Okay, you're going to have an essential quiz out of this. So you're going to have, that's going to be important. That's going to be the third and the last essential quiz. So you want to make sure you know how to do that. Okay. We are probably going to do this 4B quiz before this time because it's not related, so it's just probably going to change a little bit on that for that date, okay? And you've already done the 4B review, so we'll probably just go ahead and get that over with in the next week. So, okay, let's move on to what we're going to be talking about. So I want you to think about something. I want you to think about this. Is this statement true? Just want you to think about that. Ask yourself, is that statement true? Because that's going to be really important for what we're going to talk about next. But I'm not going to leave you with much on this. I do want to say that if you understand this, then, well, what would be true here? And how would you fill that in? You got to understand what that equal sign means. Okay, give it your best shot. And then we'll discuss it in class. Okay, so don't go ask somebody else. I want to know what you think. Okay, don't go ask your dad. Don't ask your big brother who's already taken the class and knows what it's about. I want to know what you think. And if you do go to ask somebody else, well, then what you're saying is what you think doesn't matter. And I think what you think does matter. Matter of fact, it matters a lot to me. So I really want you to give this your own thought. I want you to think about these two things. Now, when we get done with the next class, then this should be more solidified. But right now, I just want you to think about these statements. First of all, is this true? And if it is true, then, or whether it's not true or is true, then that's going to change what you do here. But I want you to think about this. Is 4 plus 6 equal to 10 minus 9 equal to 1 plus 4, which is equal to 5? Is that true? Okay. All right. So now we're gonna go down here. I just want to talk about this down here real quick because what we need to understand is if we're gonna say these are equivalent, that means we've talked about that in class already. Equivalent means they represent the same thing. I've been trying to lean into that a little bit when we talk about our fractions, and we've been talking about rational numbers, that they're equivalent. We've talked about a lot of things that are equivalent, which means they represent the same thing. And the question is going to be, do these two things represent the same thing? So again, I want you just to pause for a minute, look at these, and ask yourself, do these two things, in each situation, do those two expressions, okay, we're going to call this an expression, and we're going to call this an expression, are those two expressions equivalent? And do you think these two expressions are equivalent? I'm going to show you a way to figure that out. But right now, I just want you to spend 30 seconds looking at that. So just look at it and determine, do you think they are or not? Okay, so hopefully you took the time to think, all right, to look at that and see what you think. I'm going to show you a way to check. All right, we're going to call this substitution. In other words, we're going to put a value into x. All right, and it's got to be a couple. Now, I'm going to tell you Not that you can't use 0 or 1, but I'm going to tell you that if you use 0 or 1, you get a lot more false positives. Okay, so some people have said, hey, why are you telling them they can't use it? I'm telling you can't use it because you would get more false positives. So go ahead and write that over here, that you can use 0 or 1, but you will get more false positives. And ever since COVID, you should know a little bit more about what a false positive is. Go ask your parents what a false positive is. I'm sure they could tell you. But if you look, if you put 0 or 1 in there, you could get a false positive. In other words, it could say they're equivalent, but they're not. But most other numbers will work. You want to try maybe a couple numbers here? So we're going to try 2. I'm going to tell you I generally don't use 0 or 1. I'm not saying you can't, but I'm saying if you do, you're living more dangerously. So watch. I'm just going to put in a 2 in place of the x. Now, so one of the things you got to understand is this right here means negative 3 times x, right? Plus the 8. And we're going to put a 2 in there, which means this is going to be negative 6 plus 8, which negative 6 plus 8 is 2. Now, if these two are equivalent, then when I put in a 2 in for the x on the 3x plus 8, they will come out to be the same thing. Because if these two expressions are equivalent, then when I plug a value in, the same value in, they should come out to be the same thing. So now I'm going to say, well, I'm going to have 3 times whatever x is plus 8. And we're going to put the 2 in, which 3 times 2 is 6 plus the 8. And 6 plus 8 is 14. These two are not equivalent. 2 and 14 are not equivalent. So since those aren't equivalent, neither are these two expressions. Okay? If I put 0 in here, watch what happens when I put in 0. Negative 3 times 0 plus 8. And the other one was 3 times 0 plus 8. So negative 3 times 0 is 0 plus 8. And that's 8. And 3 times 0 is 0 plus 8. And that's 8. This test would say they are equivalent. But they're only equivalent when x equals 0. You plug any other number in there and they will not come out to be equivalent. And so when we look at this, that's the thing you have to understand. If you have someone that argues, oh, but you should be able to use 0, you now have the example that tells you why you can't use 0. Okay, so again, we're going to look at these two. Are these two expressions equivalent? Now, we said these two weren't, and we would call this our counter example right here. This is our counter example. If we can find one time when they're not the same, then we would say these two are not equivalent. So even though we can say that they are equivalent here, if you could find one time when they're not equivalent, then they're not equivalent. So we would call this the counter example. So now we're going to look at this one. Okay, so we're going to look here and we're going to ask ourselves, is 5y minus 11y equivalent to negative 6y? So as I pick a value, any value should make this work. So I'm going to pick a value and I'm going to do it. And then what I want you to do over on the right-hand side of it, pick another value. Now remember what I said. 0 and 1 produce false positives. But what you want to see is if you can find any time when they aren't equivalent, right? So if I look at this, I'm going to say 5. I'm going to pick 3 to be the place of y, minus 11 times 3. And my question is that equivalent to negative 6 times, well, that was y, so that's going to be 3, right? I'm saying let y equal 3. And so then I'm going to have 15 minus 33, which is going to be negative 18. And over on this side, negative 6 times 3 is negative 18. So these two are equivalent. Now you see if you pick another number for y. And again, I don't care if you use 0 or 1, but I'm telling you that you're going to get false positives when it's 0 or 1. So can you find a counterexample when they're not equivalent? And if you can, then you could say these two expressions are not equivalent. If anything comes in, substitute in, and they don't come out equivalent, these are not equivalent expressions. So you plug one in and you see if it works. Go ahead, take a minute, try it out. Let's see how you do. Okay, so I'm going to bet that none of you were able to find the value. Remember, you put the same value in. You could have put 6 in. You could have put 10 in. I'm just going to put 10 in real quick. If I put 10 in here and 10 in here and 10 in here, that's going to be 50 minus 110. Is that equal to negative 60? This is negative 60. This side's negative 60. Yes, they are equivalent. So far what I've seen is if I put a 3 in or a 10 in, these two expressions are equivalent. I'm going to say, I'm pretty sure these are equivalent expressions. By the end of this unit, you're going to know that these are equivalent expressions. But what we need to understand is this is the easiest and most efficient way to check to see. So that's going to be a new word, check. Checking means you're going to check to see if you have the right answer. As long as you understood everything we did before with integers and rational numbers, as long as you understand that, this is going to go all right. Okay, so my challenge to you then is to try that out with these two. And when we come back to class, when we get done with the faces of equal, we'll talk about this too. So we're going to talk about this in class. So I just want you to look at this and see if you can apply what we just did using substitution to determine if these expressions are equivalent. That's all I really want you to do. Now, the other thing we're going to talk about a little bit is these properties. Now, remember when we watched that video and it talked about the eternal principles of math? These are some of those eternal principles of mathematics. If a number system is going to be a number system, if we're going to say this number system is a quantifiable and viable number system, then what it has to do is meet these standards. It has to have an example of all of these properties. If it does not have an example of these properties, in the math world, we do not consider that to be an actual number system. In any number system, these properties must hold true. So I've been telling you about some of these properties. So what I want you to do right now is do your best to see if you can figure out of all these properties, which one of these properties fit into these. Which property is it? Just you put the number in. And you know what? So many of you are good at Google that if you wanted to, go ahead and Google it. But we'll talk about it in class. But if you really want to know these properties, these are the most important properties for you to know. We've talked about every one of these properties, but we haven't clearly, specifically identified them. So what you should do now is look at these and see if you can put them where they go. And again, this is another thing that will have you compare your notes in class. Okay, so you should be looking and seeing which one of these properties that are listed here go into these spots. So that's kind of part of your homework. And this is on your next page of your notes. I want you to do the same thing. Go in, look at it, see if you can fill in the blanks, and then tell me which property it is. What property says that 5 plus some number equals 5? First of all, what is that number? And then which one of these three properties is that naming? Should be kind of simple. When you look at this, if you don't understand this second one, we'll talk about it more in class. And I have a mnemonic to try, I have a story to kind of go with it to help you understand it. Okay. This one we have already talked about. And then my questions, what I want you to do is just on your notes, answer these questions. What did you learn from this video? What do you know now because of this video? What questions do you still have? And what's the hardest part of this lesson? What's the hardest thing on here to do? That's about it. Okay, guys, we're going to see you in class. Hopefully you've gone over this, because if you have, you're going to have more to add to the conversation than that kid who didn't. So it's going to be more fun for you. Okay, good luck.